Hey guys, welcome to 6.3. In this video, we're going to be talking about factoring a trinomial where the leading coefficient is not 1. Alright, so let's dive in. Okay, so as in 6.1 and 6.2, we factored or we took a GCF or anything like that, and that either we were introduced to a problem that had a trinomial of positive 1 out front, or we were able to get a positive 1 out front by just taking a GCF. Here, that's not the case. So here, we're going to do what they call the AC method, and let me explain to you why that is. All right, in any quadratic formula or any quadratic equation, is written this way: ax squared plus bx plus c. Okay, so that means this is a, well, number one, this is a, this is b, this is c. I am going to take that a, and I'm going to multiply it to c, and I'm going to rewrite my equation like so. X squared plus 7x plus 4 times 3 is 12. Okay, now that forces that first number to be a positive 1, and so now I can factor like I did in 6.2. So you got x, my second sign is positive, so it's going to be plus, second sign is positive, so that both signs are the same as the first, so it's going to be plus plus. All right, and then what times what is 12 and adds to 7? Well, that's going to be 3 and 4. Now here's the catch: because I started this whole problem by multiplying by 4, I have to divide by 4. Okay, so we divide both of these numbers by 4. If you do that, you can see that one of them, the second one, x plus 1, or x plus 4 over 4, that's going to be x plus 1. So that's going to reduce. I'm not going to have a main denominator anymore. But on the first one, x plus 3 over 4, I will have a denominator. And anytime there's a denominator left after reduction, all right, then you're just going to take that number and kick it in front of the x. And so this is going to be 4x plus 3 times x plus 1. And if you multiply this back out from here, you'll get 4x squared plus 7x plus 3. And so that's how this works. All right, this takes all the guesswork out of it. Let's go ahead and get started on the next one. Number 2, I'm going to take the 2, kick it to the back. So it's going to give me x squared plus 9x minus 10. All right, so let's factor. My second sign is negative, so it's going to be x plus, x minus. And so that's going to be, what times what is 10 and subtracts to 9. Well, because my signs are different, I'm trying to figure out what two terms subtract to give me 9. And so it's going to be 10 and 1. And when the signs are different, remember that this middle term, the bigger factor, in this case 10, gets the sign of the middle term. So plus 10 minus 1. Okay, now, once again, because I divided or multiplied by 2, I have to divide by 2. Okay, so that's going to be x plus 5, x, or 2x minus 1. Right, because this 2 doesn't reduce, and so it goes right there. Okay, and that's number 2. On number 3, we do the same thing. Right, you got x squared minus 23x. 14 times 3 is 42. All right, so you kind of need a list. If you don't know your factors, you get 2 and 21, 1 and 42, 2 and 21, 3 and 14, obviously. 4 doesn't go into it, it's going to be 6 and 7. Okay, so what times what is 42 and adds to 23. Because my second sign is positive, both signs are the same as the first, minus minus, which means I'm going to add, and that's going to be 2 and 21. And then I'm going to divide by 3. Right, this is not going to reduce, I'm going to kick it in front of the x. And that's going to be 3x minus 2, x minus 7. And it's as easy as that, guys. You just do it over and over again. Obviously, you run the risk of your numbers getting really big for that last term, but it's better to do that because that's only one thing to consider than to have both factors to consider on the front end and the back end. Number 4, I'm going to take 3, kick it to the back. So it's going to be x squared. It's going to be x squared plus 2x plus 33. Now, a lot of these, the factors are going to be obvious, and that's fine. So you just need to know, like 33, that's going to be 1 and 33, 3 and 11. Okay, my signs are the same, so what times what is 33 and adds to 2? Well, if we were subtracting, it still wouldn't work. But if we're adding, like none of these terms are 2 terms apart. This is what we call prime. Right? It can't factor. It's already simplified. All right, so you need to know this process well enough to know when it's a simple mistake that you've made, and I'm just as guilty as you making careless mistakes, or when the process is just not going to work. Like here, it's just not going to work out. The numbers don't crunch the way you want them to. So this one is just prime. 16 times 3. So that's going to be y squared minus 16y plus 48. If you don't know your factors of 48, list them out. You got 1 and 48, 2 and 24. And if you don't know them off the top of your head or can't figure them out, your calculator can help with this. 3 and 16, 4 and 12, 6 and 8. Okay. All right. Y minus. Right. Second sign is positive, so both are the same as the first. What times what is 48 and adds to 16. So that's going to be 4 and 12. 4 and 12. And I'm going to divide by 16. Now you'll notice, starting with number 5, I can reduce, but it's not going to reduce all the way. So I'm going to take a second and reduce. That's going to be y and 1/4. And that's going to be y and 3/4. Okay, but after reduction, I still have denominator, so I'm going to kick them both up. Okay, so it's ultimately going to be 4y minus 1 and 4y minus 3. Okay. Number 6, I'll take the 4, kick it to the back. That's going to be x squared plus 7xy plus 12y squared. And factor. Just because it has an extra variable doesn't make it more complicated. Plus plus. All right, and it's going to be y and y because that's where the y squared comes from. And then again, what are the factors of 12 that add to 7? Well, even though there's extra terms and stuff like that, this looks exactly like number 1. So let's get into it. It's going to be 3 and 4. And again, I multiplied by 4, so I'm going to divide by 4. 4x plus 3y. And that's going to be x plus 4, x plus y. Okay. Number 7. As I stated earlier, right, this is a situation where the numbers are going to start to get a little big. So if this is the only way to work it, it's the only way to work it. All right, but if they're big enough, maybe there's a GCF I can pull out. Well, let's take a look at that. Well, first of all, each term has a y on number 7, and then let's see, 3 goes in 24, 75, and 9, so I can pull out at least a 3. I'll start there, maybe I can pull out more. So it's going to be 8y squared minus 25y plus 3. Well, can't take out any more, but I was able to take that out, and now I can simplify. I can do the AC method starting here. And that's going to be 3y squared minus 25y plus 24. That's going to be y minus. Okay, that's going to be 24 and 1. Okay, and because I multiplied by 8, I got to divide by 8. Right, so it's not going to reduce, or that one's not going to go away. So that's going to be 3y times 8y minus 1 times y minus 3. There you go. All right, number 8. Once again, I got 16, 12, and 2. Also, I see a z in these terms, so let me try that. I'll take out a 2z. That's going to be 8z squared plus 6z plus 1. Remember, when going back to 6.1, when it talks about GCF, if the GCF is one of my terms, I replace that term with a positive 1. Okay, so that's going to be, I'll take that 8 and take it to the back. So it's going to be 2z squared plus 6z plus 8. 2z plus, and that's going to be 2 and 4. I'll divide it by 8, or multiply by 8, so I got to divide by 8. I'll take a step and reduce this. So it's going to be z plus 1/4 and z plus 1/2. Okay, I'll throw those denominators in front. And then I'll finish this up. All right, 2z times 4z plus 1 times 2z plus 1. There you have it. All right, guys, that's 6.3. Hope you got something out of it. If you have any questions, please reach out. I'll see you in the next video.